Hello everyone. Today we shall discuss about current electricity. Chaotic flow. Millions of amperes are released in unpredictable bursts. Steady flow. Microamperes channeled precisely to power our world. Understanding the mechanics of moving charge from the invisible atomic scale to complex systems. Defining the flow of charge, current I, the net amount of charge flowing forward across a specific area in a given time interval. I is equal to limit del t tends to 0 del q by del t, and that is equal to del dq by dt. Context note: 1 ampere is a unit, the standard flow rate for domestic appliances. Nerve impulses operate in mere microamperes. Inside the conductor, here you see no electric field is there, so every velocity is 0. Electric field applied. Solid conductors carry current via negatively charged electrons moving against a background of fixed positive ions. Thermal motion is fast but random. Electric field provides the directional push. The slow march of drift velocity. Drift velocity equal to minus small e capital E by small a into tau. E is the electron charge, capital A is the electric field, m is the mass, and tau is the relaxation time, average time between collisions. Key insights: despite current establishing instantly at the speed of light, individual electrons actually drift at speeds of merely a few millimeters per second. Ohm's law and the geometry of resistance. The fundamental rule V is equal to IR, that is voltage equal to current into resistance. The resistance is not just about the material, it is about physical dimensions. R equal to rho L by A, where rho is the resistivity, is the intrinsic property of the material. L is the length and A is the area. Current density and conductivity. Current density, current per unit area normal to the flow, J equal to I by A. Ohm's law, vector form, J is equal to sigma capital E. Here sigma, the conductivity, is the inverse of resistivity. Sigma equal to 1 by rho. Microscopic link, J equal to NeVd, number density into charge into drift velocity. Breaking the rules, limitations of Ohm's law. You see non-linear heating. This is sign dependent diode. This is non-unique GAS, right? Ohm's law is not a universal law of nature. It is a behavioral approximation that fails in modern semiconductor devices. A heat of the current. As electrons collide with atoms during their drift, kinetic energy is transferred as thermal vibration. The conductor heats up. Power dissipation, ohmic laws, P equal to IV, P equal to I square R, or V is equal to V square by R. Real world application. High voltage is used in long distance power transmission to minimize current, dramatically reducing power loss I square R in the cables. The engine, cells, EMF and internal resistance. Electromotive force, the potential difference between electrodes in an open circuit. Note, it is a voltage, not an actual force. Internal resistance, the electrolyte itself resists the flow of current. So epsilon is equal to I, capital R plus small r. The maximum current a cell can draw before damage is I max equal to epsilon by small r. Combining forces, cells in series. When cells are connected in series, their voltage and internal resistances add together. Equivalent EMF, equivalent is ER, E1 plus E2. Equivalent resistances, ER, equivalent equal to R1 plus R2. Rule of thumb, use series connections to boost total voltage. Splitting the load, cells in parallel. When positive terminals are joined together and negative terminals together, the current splits. Equivalent resistance 1 by R required equal to 1 by R1 plus 1 by R2. And equivalent EMF equal to EQ by R equivalent equal to epsilon by R1, epsilon 2 by R2. Governing the chaos of complex circuits. Simple series and parallel rules fail when circuits branch unpredictably. The solution: Kirchhoff's rules, a systematic method to determine every current and voltage in any circuit network, no matter how complex. Kirchhoff's junction rule, the principle of charge conservation. Charge cannot accumulate at a junction. What goes in must come out. The rule, the sum of the currents entering a junction equals the sum of currents leaving it. So equation summation I in equal to summation I out, that is I3 is equal to I1 plus I2. Kirchhoff's loop rule, the principle of energy conservation. If you walk in a closed loop, your net change in elevation is zero. The rule, the algebraic sum of changes in potential around any closed loop must be zero. That equation summation del V is equal to 0. Here you see resistor voltage drop, battery voltage gain, and you see resistor voltage drop. Application: the Wheatstone bridge, a precision arrangement used to determine an unknown resistance. The null point condition: when the bridge is balanced, the potential difference across the center is zero. No current flows through the galvanometer. So the balance equation R1 by R2 equal to R3 by R4. By doing the three resistors, the fourth can be calculated with perfect accuracy. These are the applications of Wheatstone bridge. Thank you everybody for watching this video.